It's an exciting day here. Saxon Algebra 1. We are doing lesson 83, and we're going to tackle something we've been preparing for. It's called coin problems. These are a classic favorite in algebra. Ask any adult if they remember coin problems in algebra. They'll probably say they don't remember how to do them, but they remember doing them. And you are now going to get a chance to learn them for life. It's going to be fabulous, okay? Let's dive in. Let me just read it to you first. Don't try to make sense of it. Just listen to what the story's about. Jack and Betty have 28 coins that are nickels and dimes. If the value of the coins is $1.95, how many coins of each type do they have? Okay, we just heard two statements about Jack and Betty and their coins. One was a quantity statement. We heard something about how many coins they have. Okay, that's the individual coins. It has nothing to do with what they're worth, just how many coins did they have. And then we heard a value statement. And that was what they're worth. Okay? That's the way coin problems always work. And then there are a family of problems that are related to this that aren't specifically about coins, but use the quantity and the value statements. We will get to those eventually, but today we're only looking at coins. What we're going to do is we're going to write one equation about the quantity of coins and one equation about the value of the coins, and then we're going to use them together as a system of equations to solve. The variable that we use is what you've been practicing. In this case, we have nickels and dimes, right? So n is going to be the number of nickels. Get it? And nd, guess the number of dimes. So what we're talking about in this variable is more of a quantity issue. It has nothing to do with how much these nickels are worth, it's just how many nickels we have. So we'll use this number to write our equations. So let's go back to the book and see what we've got. Jack and Betty have 28 coins that are nickels and dimes. So the number of nickels they have plus the number of dimes has to add up to 28 coins in all. That's our quantity statement. Now, if the value of the coins is $1.95, how many coins of each type do they have? Okay, the value is $1.95. So when you find the value of the nickels, you count up the number of nickels, and you know they're 5 cents each. So 5 times the number of nickels, 5 cents times however many nickels you have, plus dimes are number of dimes equals, now I'm going to do something that's wrong right here, and then we'll fix it, $1.95. Okay? Now, what I've done wrong is I've stated my money in two different units. Here I'm using cents, right? 5 cents and 10 cents. But here I'm using dollars, $1.95. So we could write the value of the coins in decimals. This would be 0.05 and 0.10. And then that would stay the same. But I don't want to do that. I don't want to put a bunch of decimals. So what we're going to do is we're always going to state what our coins are worth in cents. That's a cent sign, right? So I'm not going to use that. I'm going to use 195 cents. Does that make sense? Ooh, see what I did there? That was a little intense. So we restate our value in terms of cents by taking the decimal out. All right, now we have our system of equations, and we are ready to rock out the algebra part of this. Now, we have our choice of substitution or elimination. If you were here, I would let you choose. Since I'm here, let's do this. Let's do substitution this time, then we'll do elimination the next time. And then for the third problem, I don't know, we'll figure that out. So what I'm going to do is I'm going to subtract the number of dimes from both sides. I could have done it the other way. I could have kept that here and subtracted this, but I'm just making it as simple as possible. So then I will get the number of nickels equals 28 minus the number of dimes. Okay, then I'm going to substitute that into this. 5 times the weird thing that we're substituting plus 10 times the number of dimes equals 195. Decimal gone. And the other thing I always check once I've substituted is I should just have one variable now, and I do. Yay. All right, we better distribute. That will be 140 minus 5 times the number of dimes plus 10 times the number of dimes equals 195. So far, so good. I'm going to subtract 140 in the same step that I put those two together. So that's gone. These two combine to 5 times the number of dimes equals 55. Divide both sides by 5, and I get that the number of dimes equals 11. All right. I feel good about it, you guys. And now the last step is to find the number of nickels. And so we go back. Excuse me, yawning. We go back to our original equations and look for the easiest version of this. Well, here, this is perfect, right? The number of nickels equals 28 minus. So the number of nickels equals 28 minus the number of dimes, which is 11. So the number of nickels equals 17. And I don't have to write these as an ordered pair. You know how we've done that a lot. But these aren't an ordered pair so much as they are two different values. So the number of nickels is 17, the number of dimes is 11. That's right. Yay, us. Your first point problem. Look at what I did. I have mutated this person, this smiling person, so their eyes are above each other, above and below. It's not okay. They must have COVID-19. I don't think it causes our faces to mutate. Never mind. Example 83.2. Ming has $4.45 in quarters and dimes. Okay, that sounds like the value one for me, right? Because it's got the dollar amount in it. Let's find another sentence that says something about the quantity, right? So sometimes it helps to do this when you're getting started, to remind yourself you need a quantity statement and a value statement. The value statement talks about how much they're worth. We want to just know how many coins. She has 8 more quarters than dimes. Okay, so I'm going to write an inequality first. She has more quarters than she has dimes. The difference is 8. So if I add 8 here, the number of quarters, sorry, I didn't do that right. The number of quarters is greater than the number of dimes. 8 is the balancing number. If we add 8 to the number of dimes, then we have the same amount. The value statement is that she has $4.45. So 25 times the number of quarters, because quarters are worth 25 cents, plus 10 times the number of dimes equals 445 cents. I changed it from a dollar amount with the cents. Okay. Looks good. So now, well, I should have used substitution on this one, but that's okay. Yeah, we'll substitute again, and then the last one will work for elimination. The way we wrote this equation, it's just perfect, isn't it? So we're going to substitute this in for the n cubed. So 25 times number of dimes plus 8 plus 10 times the number of dimes equals 445. Substitution. We distribute 25ND plus, like, if I think of quarters with this, 4 quarters is $1, so 8 quarters must be $2, so that will be 200 plus 10 times the number of dimes equals 445. I'm going to subtract 200 at the same time that I combine like terms, and I get, that's gone, 35 times the number of dimes equals 245. Divide by 35. Right? That's gone. And let's do a little long division over here. 35. That's not a decimal. I accidentally wrote it like it was a decimal, but that was wrong. Okay, 3 times 8 is 24. But then when I multiply the 5 in there, it's going to be too big. So I'm going to go with 7. 7 times 5 is 35. 3. 7 times 3 is 21. Plus 3 more is 24. Oh, so it worked out. That's 7. So the number of dimes equals 7. These numbers always come out cute, you guys. John doesn't do anything weird with fractions or decimals. And then to find the number of quarters, it's the number of dimes, which is 7 plus 8, so that equals 15. Yay! Those are the right answers, and I'm just going to box all of that. Okay? Third problem, final one for this lesson. We'll use elimination. Orlando had a hoard of 22 nickels and dimes. Ooh, I stop right there. That's my quantity equation, isn't it? There are 22. So the number of nickels plus the number of dimes equals 22. Now let's find out how much they're all worth. And their value was $1.35. So now I put the value of each coin in front of it. 5 times the number of nickels plus 10 times the number of dimes. I'm writing in cents rather than dollars. Equals, what did I say? 135 cents. It's $1.35, the way it's written. Okay? And John handles this issue with the pennies and the dollars just like I do. So if you look in the book, you won't get confused. Sometimes John and I do things differently. I know, shocking. But in this case, we don't. We're exactly the same. So everything's good. Okay, so this time I want to use elimination. So I look at my ends. This is an invisible 1 and a 5. This is an invisible 1 and a 10. Everything's positive. So I'm going to eliminate the number of nickels, and I'm going to do that by multiplying this top equation by -5. And then I will rewrite it down here. So that will be -5 times the number of nickels, -5 times the number of dimes. 5 times 22 is 110, so that will be 110 minus. Elimination, our old friend. And so that cancels. 5 times the number of dimes equals 25. Divide by 5, the number of dimes equals 5. And then we know that they have to add up to 22. So I'm not even going to write an equation. I'm going to live on the edge, you guys, and write 17. All right? And that's the correct answers. Okay? Quantity and value statements, use cents to describe all your money. Remember how much each coin is worth. And you've got it. Those are our coin problems, and you are super smart because I know you're going to figure these out in no time. See you in lesson 84.